Hello everyone. Today is December 15 and we are almost halfway done with our coding advent calendar. Let's solve the problem for today provided by LeetCode and improve our skills. Welcome to my YouTube channel. Don't forget to press like and subscribe. Let's start. Okay, here is the problem. Longest common subsequence. Given two strings t1 and text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string, which with some characters can be deleted without changing the relative order of remaining characters. For example, ACE is a subsequence of ABCDE. ACE. So it's not necessary that they should go one after another. A common subsequence of two strings is a subsequence that is common for both strings. For example, ABCD and ACE. Output should be 3 because ACE is here ACE. Okay, next example. ABC and ABC. 3 ABC, they are the same. Their length of the length is 3. Example 3. ABC and DEF. Nothing in common, so we should return 0. Okay. So you can see there the description. Let's solve it. I'm going to show you interesting trick here, how to solve this problem. And in order to do this, I will need some comment here. So let's say we have two strings. One is Abra and another is, well, guess. Cadabra. Okay, what are we going to do? We are going to do it to check this in a backward order. So for example, we have string A and A, so they have one in common, right? Let's do it like this. We will create a two-dimensional matrix and we will set 1 here because A equal to A. So if we consider two strings A and A, we have one in common, right? Okay, here in this position of two-dimensional matrix, we're considering RA and A. They still have one in common, right? And what we're going to do, we will take this one and move it here. R and A, and we will have 1. Okay, in this position, we will consider B, RA, and A, and they have only one in common, right? Here we have Abra and A. They have only one character in common, which is A, no matter what A, this one or this one. So we will set 1 here. And in order to support this we will do the following. We will add like full positions here, which are full of zeros. See, we will add one more layer here. See the magic of numbers. Okay, so what is our strategy? If we have A and A here, if we see the common character, we will do this. We will take the position to the right and down and add 1 to it. So A and A here, so match. We will take this 0 and add 1 and put it here. If we don't have any match, we will take maximum of this 1 and this 0, and it is 1. If it's B, we will take maximum of this 1 and this 0, and it is 1. If it's A, this is match, and we will take this 0 and add 1 here. So diagonal increment. So it is 1, and so on. So B, A, and we consider Barbara and A. So they have only 1 in common, A, this one or this one. So we use maximum of this 1 and this 0, and it is 1. Again, A, we consider a Barbara and A, and it is also 1. And C, so Kadabra and A, the common character 1. Next one is more interesting. So we consider A and Ra. They have only 1 character in common here, and what we do here, since A is not equal to R, we take the maximum of this 0 and this 1, and it is 1. If it's okay, so next we consider Ra and Ra. They have 2, like they are the same, 2 characters in common, so we take this one and add 1 in diagonal, so we have 2 here. Next, B. B is different than R. We consider two strings, Bra and Ra, and we have 2 because Ra is in common and it's 2 characters, and so on. A and Abra and Ra, 2. Dabra and Ra, 2. Adabra and Ra, 2. Kadabra and Ra, 2. Okay, next we consider A and Bra. Right? A and B are different characters, so we take this one and put it here. Ra and Bra. Right? This R is different than B, so we take maximum of these 2, and this one we take 2. Bra and Bra. Right? B is the same here, so we take these 2 and increment it by 1. It is 3. Abra and Bra. 3 characters in common, we take maximum this 3 and this 2, we have 3 here. Dabra and Bra. T and B different, we take this 3 or this 2, 3. Adabra and Bra. We take 3 from here. Kadabra and Bra. We take 3 from here. Next, A and Abra. We have AA here, so 1 in common, and we take this 0 and set 1. Ra and Abra, 2 characters in common, this Ra and this Ra, and we take maximum of these 2, it is 2, right? Bra and Bra, we take this 3 from here, abra and abra, so A and A are in common. We take this 3 and add 1, so we have 4. Dabra and abra, we take this 4. A and adabra and abra, so it means that we can take this A and this B are A, like this, or we can skip this A and this B, and we take A, B, R, A. So it's still 4. So this 3 plus 1. And okay, adabra and abra, the same thing. We take the 3 and add 1. Here we have 4. And from here we have 4 from here. And our result will be here at position 0 in two-dimensional matrix. So this is a trick to split initial solution into many sub-solutions, and using this two-dimensional matrix we can using this trick we can solve this problem by moving from sub-solutions into our original solution. Let's implement it. Okay, our function needs to return integer, and let's create a two-dimensional array. And for simplicity, let's say this is T1 and this is T2. T1 yeah, and we will add one here for these zeros, and 1 here for these zeros. So we will not get to the out of range of this array in our solution. So next we will move from the ends of these two words to the beginning. So we will move backward. For int column equal to T2 length -1, column more than 0, more or equal than 0, call minus for int row equal to T1 length -1, row more or equal than 0, and row minus. Okay, next, if T1 row equal to T2 row, yeah, column, yes, because one is aligned along rows and the second one is using columns. So our array row column will be, so if it's the same, we will take next position, diagonal position, and add 1 to it. 1 plus array row +1 column +1, else array row column equal to max of array like down and right. Row plus 1, column, and array row column plus 1. That's it. And as a result, we need to return the position 0. So our algorithm should work, and it should do these manipulations with integers, and we need to return array 0, 0. That's it. Let's try. Okay, string does not contain yes. Okay. That's it. 3 cases are accepted. Let's submit. Okay. We have done, and our solution beats 84 at 85% of all solutions. Let's estimate the complexity of our algorithm. So the time complexity is big O of mn, where m is the length of the first word and n is the length of the second word. So we have multiplication of these two words because we have two-dimensional matrix. And we also have a memory consumption of big O of mn because as well we have two-dimensional matrix. So this is enough for our solution. It can be optimized somehow, and I offer you to find this optimization here. It can be optimized. That's it. Well, this one was a little bit tricky. I offer you to go through the examples of your choice and understand why the solution works this way. If you have any questions, don't hesitate to write a message for me in comments. See you tomorrow.